Hi everyone. In this video, I am going to talk about the key pointers that you must have on your fingertips in order to ensure that you are hardly making any kind of mistakes when there is a question in front of you with respect to logarithmic or exponential functions. Over here, my main focus would be to show you what are the different types of questions and connect it with this kind of ideas that I've written over here so that you can identify the moment you're looking at the question, okay, yeah, I know this is this type of a question and it has to be solved in a particular format. And once you're able to identify this, logarithm chapters becomes very easy. Now, apart from the applications that you're seeing over here for the commonly asked questions, logarithm is one of the things that is present widely across your P3 syllabus. You can find logarithms in your integration, you can find them in differentiation, you can find them even inside the modulus functions. So it's really good if you are learning logarithmic manipulations. Just be good with it and you will find your life easy in your P3. Okay, I've seen a lot of students struggling just because they are not good with logarithmic manipulations, specifically the power rule. Let's say if I'm giving you ln of 8, if I ask you to convert this into 3 ln 2, how will you do this? You need to know the power rule. You need to know that ln 8 can be written as 2 cube, and then I can bring the power 3 down and I can get this format. So there are a lot of different kind of manipulations that you just get better at it with practice. So yeah, this is one topic which you can master not by actually solving the logarithmic chapter questions, but solving its application based questions that you can find in differential equations and integrations. In those kind of chapters, you will see that, oh yeah, now I know how to manipulate the logarithmic functions. But yeah, for now, let me get started with the key pointers, at least for this chapter. So the first thing is you must know all the formula with respect to logarithms on your fingertips. That is multiplication and addition. What is this formula? I know that ln of a multiplied by b, this can be written as ln of a plus ln of b. Now one important thing along with this is, please note that ln of a plus b has no formula. You can't distribute ln to a and b because ln is not a number. It is just a function and a plus b are its input. So there is no formula or a way to expand this thing. But let's say if you're given ln of a plus ln of b, then you can always convert this into ln of ab if required. Or the other way around, you can go from this format to that format. And similarly for the division and the subtraction rule, if you are having ln of a divided by b, this is same as writing ln of a minus ln of b. Now let's say if you are given ln of 2 plus ln of 3 minus ln of 7 plus 2 ln 3 minus ln 6. If I want to convert this into one single ln term, how can I do it? You also need to know over here the power rule. See, for every coefficients of the ln, if you see, all of them are either 1 or minus 1, except this one. So what you do, before combining the logarithms together, make sure that the coefficients are same. Over here, what you're going to do is, first of all, you're going to use power rule to convert this to from here to the power of 3. That is going to become 3 square. And after that, what am I going to do? I'm going to say that whatever terms which are added together will be on the numerator, and whichever terms which are subtracted will be in the denominator. So let's say this term can be written as ln of 9. So if you try to solve this, it will become 2 times 3 times 9 divided by 7 into 6. I can use ln of a plus ln of b, and using that I can write this as ln of 2 into 3. Then ln of 2 into 3 plus ln of 9. So again I can use the uh, addition multiplication rule so that you get ln of 2 into 3 into 9. And then because you are having all of that minus ln 7, you are using ln of this over 7. And then again you are having minus ln 6. So again you are having 6 in the denominator. So a quick trick to remember this is, whatever is in the plus sign, have that on the numerator. The input of the ln with the plus coefficients, have that on the numerator, and the inputs of the ln with the negative coefficient, have them in the denominator. And make sure that the coefficient value, the magnitude of the coefficient, is always same while doing this manipulation. This is one important manipulation that is going to help you a lot in the entire P3. Then of course I am sure that you're aware about the power rule. The second thing that you must have on your fingertips is You must know when and how to introduce logs on each side and when and how to remove the logs. So let's say if you're having certain kind of an equation like this. Over here, whenever your variable is on the power and you are trying to solve for that particular variable, that what is the answer for this x? So you need to bring that x down. So whenever you want to bring x down, in that case, you need to introduce logs on each side, and both the logs should have same base. It could be either log to the base of e, which is natural logarithm, log to the base of 10 on both the sides, or whatever base. You can have log to the base of 3 on both the sides. Until the bases are same on both the sides, you can use log with the any base. Okay. The common thing that we usually do is either log with the base of 10 or ln on both the sides. That is when we introduce the logs, when we want to bring something from the power to the bottom. And then how do you remove the logs from the equation? For example, let's say I'm having this equation. On the left side, I'm having ln of x cubed minus 3. And on the right hand side, if I try to club this together, for that, I need to make sure that 3 is going in the power so that I'm having the coefficient as 1 on both the cases. So it will become ln x cubed minus ln 3. And then if I simplify this using ln of a by b formula, it will become ln of x cubed over 3. And now because you are having ln on both the sides, how can you remove the ln? Because you are trying to solve for x, you need to get rid of ln. You can't simply cut it like this. This is wrong thing. What you do instead is you're going to raise both the sides to the power of what? Of the base of the logarithm. In this case, I know that it's log to the base of e. So I am going to have e on both the sides and raise the entire thing on the power. So it's written like e to the power of ln of x cubed minus 3 is equals to e to the power of ln of x cubed by 3. Now, what is the reason behind this? Whenever you are having base of the logarithm with the same base, whenever these bases are equal, at that time, whatever is your input, okay, whenever you are having this format, this is same as writing your just input without the logarithm terms. So now, whenever you want to remove the ln, don't just cut it directly like this. Actually, you are introducing the base of the log on each side and raising everything in the power, like what I have shown you over here. And now over here, because it's like e log to the base of e x cube minus 3, this is same as writing x cube minus 3 is equal to, this is same as writing x cube over 3. Now you can see that you can easily solve this equation. So that is how you should be aware about how to remove logarithms. Now the third key pointers that you must have on your mind is the common type of questions that are repeatedly asked in the chapter. And these are the type of questions that I was talking about. In one question, you are having logs on both the sides. In one question, you can see that there is log and non-logarithmic terms in the same equation. So in this case, what you do, you take logarithms on one side and keep the constants on the other side. In that case, you will need to get rid of the ln terms. How you can do it? By bringing e on both the sides. After first merging ln terms, you must have same ln term, and then after that you can bring e on both the sides and raise both the sides to the power. I'll show this to you in the individual video when I start doing the questions. Then there is one more type of the question where you can see that you are having exponential terms in your equation. Whenever you're having something like this, you can try to say that 4 to the power of x is equal to u. So what does this become? This will be 4 to the power of x by 4 square, which is 16. So this can be written as u over 16 is equal to u minus 16. So whenever you see something like this format, you can convert this into the format of u and try to solve. And there is one more type of a question that is with respect to the graphs. You must know how to take any kind of an exponential function and convert it into the straight line graphs with the help of logarithms. You can introduce logarithms on both the sides so that the powers can come in the bottom using the power rule. And then whatever is the relationship that is asked in the question, you can try to derive that and convert it into the y equal to mx plus c formula. So these are the common type of questions that you must have on your fingertips. Now, you must know how to use modulus function to solve log and exponential question. I am talking about this kind of a question. You can again say that 5 power of x is equal to u. So it's like 4u minus 1 inside the modulus is equal to u. Now you can open the modulus once with a plus sign, once with a negative sign and solve for u. Once you are done getting the value of u, you can substitute 5 power of x in place of u and try to solve for x. Apart from that, you should know how to convert an exponential equation into the form of straight line. I am talking about this part. And then there should be a clear-cut understanding of inverse relationship between the log graphs and the respective exponential format. I'll show this to you on the Desmos in a couple of seconds. And lastly, you should know graphs of logarithms and exponential functions are usually paired up with the numerical solution chapter, because you must have seen that in the numerical solution chapter, they ask you to sketch the graph and show where is the point of intersection. So in those cases, they mostly ask the graphs of logarithms, exponential terms, etc. But now let me go ahead and show you on the Desmos what's the relationship between the logarithm and its respective exponential form. So look onto the graph over here. The blue graph is for the exponential function. The red graph is for the logarithmic function. The important thing that you need to pay attention is on the base of the log and the base of the exponential over here. So I know that a is the base of log, and for the exponential I'm using a to the power of x. And y is equal to x mirror line is drawn over here to show the inverse relationship between the log and its respective exponential function. As you keep on increasing the value of a, you can see that according to the mirror images, they are exactly working like how you expect inverse function to work. So this is the relationship that I wanted to show you. As such, I haven't seen a direct question on this, but being a P3 student, you must have a understanding that how logarithms are connected to its respective exponential function. I hope this was useful for you. In the next video, I am going to go ahead and solve some questions that I had shown you earlier. Let me show that to you once again. Yeah, all the questions that you're seeing in the PDF over here, I will be solving all of them one by one. So yeah, I will see you over there.